Okay, I'm working on step 5, which is for 8th grade only. Already have a video posted in your instructions about how to find a line of best fit or a model for the exponential or the linear function that you found. So do that first. And then once you've come up with a model, you're going to use the model to make a prediction about what's going to happen a generation from now, 20 years from now. So I'm doing that down here. Here's the model that I came up with by using the steps in the previous video. And 20 years from the last piece of data that I have on my graph would be 2035. So I know it's not 2015 right now, but the last piece of data I have on my table and on my graph is from 2015. So 20 years from that would be 2035. Remember that on your table or your graph, your y-axis is not listed the number of years or the actual year. It's listed how many years since you started. So on my graph, it's how many years since 1915. Just to go back to the graph to show you that again, what I'm talking about is down here, years since 1915. So if I wanted to go figure out how many people would be projected to visit in 2035, that's 120 years after 1915. I don't have that on my graph, but that's what I'm figuring out now. What would that be? Okay, so the x is the number of years after 1915. That's the exponent. So I just figured out it's 120 years since 1915. So I put that in place, and I'm going to use my calculator to figure out what that actually equals. And 86643.452. Yeah, I'm making a video for the 8th grade. That's okay. Mr. Wilson just came in with some students. It's okay, you guys can stay. The 8th grade will love this. Okay, so I just entered the equation that I found, my model, and I put 120 as my exponent, and it says that based on that model, I can expect that, 1, 6, 2, 8, 3, 1, 4, 6. I'm going to round to the nearest whole number of visitor. So 16,283,146 people can be expected to visit in 2035. So the next part of this is to say, is this prediction reasonable or not? So one way to figure that out is to think about how many, like what percent of the population visited in 2015, and then what percent of the population would be expected to visit in 2035. So basically, the number of visitors is going to increase, but the number of population, the number of people living in the United States is going to increase as well. Are they increasing at the same rate? That's what we're going to find out now. So the percent who visited the Grand Canyon National Park in 2015. We have the information on my table and in my graph that there were 5,520,000, I'm writing this over here on my paper, 5,520,736 visitors in 2015. And I want to know what percent of the population was that. So I'm going to divide that by the actual population in 2015. So there's a link in your directions that will bring you to this page, and it says that the population in 2015 was 3 to 1. So this 0.37, it says that it is the number of residents in millions. So 321,370,000 is what that number actually is. I'm going to write that here. 321,370,000 100,000. And we'll see what that equals when I divide it. It should be a decimal that I'm going to turn into a percent. So 5520736 divided by 321370000. Okay, so it equals about, we'll say 1.7, whoops, it equals about 0.17, which is about, oh man, I messed it up. You guys are going to be wondering, why didn't she just stop the video and start over again? It has so many interruptions and mess-ups. Okay, here it is. 0.017 approximately. So that is about 1.7% of the population of the United States visited the Grand Canyon. This is like very sketchy because people from other countries also visit the Grand Canyon. It's not only people in the United States, but it's one small way to like try to get a handle on whether or not your number from your equation actually makes sense. So the percent expected to visit, according to what we calculated up here, would be 16,283,146, and the whole population in 2035, according to this table, is right here, 2035. So I'm writing this down, 370,340,000. Okay, so that's our projected visitors, projected population. Let's figure out what that equals. 6, 2, 8, 6. Okay, so that equals about 0.044, we'll round it, which is 4.4%. So I think this looks a little high. The projection looks a little high. Like more people, the increase in the number of people is going to be faster, people visiting, I mean, is going to be faster than the increase in actual population. So I'm going to write that up, and I will link the like typewritten explanation of that into your instructions so you'll see an example of what you need to do once you've done this math.